This video is part of the series on the Control101 MATLAB toolbox, and this one is looking at a PI tuning app. So the community's agreed on an outline structure for a Control101 course, and this toolbox is basically been designed to support that course because MATLAB tools are really ideal for control engineering, and they support visualization and number crunching. This particular video is going to look at the tuning of simple PI compensators, something like you can see here, so Ki over S the integrator and Kp the proportional. And why? Because these are very widely used in industry. There are a large number of different tuning rules for PI compensators available in the literature, all based on slightly different assumptions. But it's not the purpose of this app to explain those tuning rules, but rather to provide a framework where students can practice efficiently. So we allow users to modify a parameter and update the behaviors instantly, thus quickly viewing and comprehending the impact of any tuning changes. So specifically, students can change Ki and Kp and see what the impact is. Some notional tuning guidance then. If you're beginning from a low value, increasing the proportional term will tend to speed up the transient response because it makes the initial input larger. However, it can also cause underdamping and instability if you make it too large. Similarly, if you're beginning from a low value, increasing the integral term Ki can make the convergence time quicker. For low-order overdamped systems, this observation is fairly consistent. However, it can also lead to underdamping and instability, especially if the values are too high. And we should also note that the limits on the integral term are often linked to the choice of the proportional term. So if Kp is smaller, then you may only be able to tolerate a smaller Ki before you get underdamping. The tuning app then. This app allows users to enter a variety of systems, you can see in the top yellow box, and also different values for Kp and Ki, and also to include disturbances if you want to see how the PI responds in that scenario. The results show the step response and the closed loop pulse. There is also a manual which will open automatically when you run the app. So let's do a live demonstration then, and you can see roughly how this app works. So here's the app. You can see you can choose some random models, first order, second order. Well, not random, these ones are fixed for convenience. Okay, but that just makes it simple if you want to make a start. So you can choose the values for Kp and Ki in the sliders, and you'll notice I've got a non-zero disturbance down here. So I press simulate, and let's see how this works. Now you'll notice the disturbance comes in at 2.5 seconds deliberately so that you can see the impact. You see what's the response without the disturbance and how do I behave when a disturbance occurs. And I can do systematic studies. I can change Kp and simulate again, and you can see slightly larger Kp, slightly faster response in transients, but not necessarily faster convergence here because I haven't changed Ki. Now what I'll do next is I'll switch the animation off so that this goes just slightly quicker. So that's quite slow, probably because the video recording is happening. So I switch the animation off. I can now increase Ki, and hopefully you'll see slightly faster convergence time. So you can basically perform systematic experiments. I can change the system. What happens if I have a second order system? Oops, I've pressed the wrong button somewhere there. So let's simulate. And you can see, again, you can investigate the different behaviors with the second order system. I can also, if I want, put in numbers of my choice in here, and it will run with those numbers. So some conclusions. We've demonstrated how to run and use the PI tuning app in the Control101 toolbox. These can be deployed during lectures or student private study to help students appreciate and relate their technical and analytical learning. The manuals contain some individual MATLAB source code that can be used as templates for individual investigations. So for example, I've limited the ranges of values of Ki and Kp in the app, and they might want to go beyond that, so they would need to use their own source MATLAB code.